Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗚𝗟𝗟𝗟 and today I'm very excited because I'm gonna introduce you to one of my favorite vulnerabilities, which is the buffer overflow. So we'll start by explaining how the stack works, what is a buffer overflow, how to exploit it, how to write it, and yeah, let's start. So we start by creating our first program. And this one is for later on, this also, and we start with main, return 0, and let's start by initializing a buffer of 0x20 bytes and initialize it with 0, and then let's say printf what's your name boy, and then scanf %s and write it to name. So if you have noticed, something is already sus here. If you have already found the bug, good job, we're on a good way. But let's proceed. Printf yo what up %s and the name. So this is our main program. There is a car buffer of 0x20 bytes. It asks for a name. It stores the name we enter in the name buffer, and it says printf yo what up and the name we entered. So let's go, and we're gonna compile the source code into a binary. We're gonna do gcc buff.c and fno stack protector, because we don't want to have the canary here. We'll explain in the next video what the canary is, and does so for the output name both, and we run the program. What's your name boy? 𝗪𝗚𝗟𝗟𝗟, yo what up 𝗪𝗚𝗟𝗟𝗟, nice. And let's try again. What's your name boy? My name is and we see segmentation fault. Okay, this is not the intended behavior of the binary. It should say yo what up, but it didn't. And why is that? That's because we overwrote the return address. But what is the return address? Let's open a debugger and breakpoint at main, run the program, and I'm gonna zoom out a bit so I can see the commands. So we see here that it allocates 0x20 bytes from RBP, and here it's gonna save what we enter as name, and we continue. We have reached printf what's your name boy, and continue, and we are at scanf here, and when we press enter, what's your name boy, 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 6 5 6 7 8. I cannot count, so let's stop here, and we see that our string starts from this address. So let's copy that and do x20gx this address to see what it has, and as expected, this is the address we examined, and the first column is where we start to write from right to left, and this is our A's, A. This is the B, this B, C, and here are some zeros because we didn't write anything at this point of the buffer, and then we have a nice address here and another address here, What are these? Let's say here temporary, we have this and this, and we continue, blah blah blah, printf, yo what up, and then the program is going to leave an ret. So it's gonna return somewhere. It's gonna return to this address and call exit and leave. And what is this address? 2A1CA. 2A1CA. So this address was our return address. Ret address. And the other one here is the RBP. It's not the RBP here, it's, where is it? FDCME then, yeah, it's the RBP that shows here. So this is the RBP. Let's take a look again here. Yeah, these are the same addresses, DCME then and 1CA. So this one here is the start of our buffer, which is, this is 8 bytes and another 8 bytes. So in hex this is 0x8, 0x10, so 0x20, that's our whole buffer, which is 32 bytes in length. And then we have the RBP and then the return address. The return address is where the program intends to go in its normal flow. So what happens if we override this? If we override this, the program does not know where to go. Let's try this actually. So yeah, next, scanf and a couple of A's. And right now we see that we have overwritten the return address with some junk, with arrays, and continue, printf, blah blah blah, leave ret, and we see that the program is trying to return to 0x41, to our arrays, and it will produce an error, 𝗙𝗟𝗟𝗟𝗙 fault. Okay, so the program crashed because it tries to go to an address that does not exist in the binary, which is this, that we overwrote the return address. And okay, so we explained that inside the debugger. Let's also see it here. So this is the stack, a very nice representation of me here, and we see the start of the buffer. Let's say name 0 to name 7, this is 8 bytes. We start by filling it with A, 1, 2, 3, 4, 1, 2, 3, 4, and then we added some B's, B, and then let's say some C, and the D's, D's nuts, and after that it is the RBP. So this is the intended length of the buffer, 32 bytes, because each cell here is 8 bytes. As we can see, also let's say a helper tip I have here. One character in C is 1 byte long, so this is 1 byte, 1. So this is 8 in total, and this one is an address, and the hex value of A is 0x41. That was so we can understand it here better. And B is 0x42, yada yada. And let's say, okay, we fill the buffer, 32 bytes of junk, and then scanf. The problem with scanf is that it stops only when it reads a new line, or null byte, I think. It will not stop, and because it says, okay, this is the end of our buffer, and I stop reading. No. It will stop until it gets enter. That means we can continue writing, and what we will overwrite, we will start overwriting RBP. So here we can say another A. hey. And if we continue, we will override the return address. So the program, instead of the program was going to exit normally. But if we override this with, let's say, b, the program will try to go to this address. b. And this address does not exist in the binary. So the program will just create this segmentation fault because it tries to go to an address that does not exist. This is, in very simple terms, what a buffer overflow is. You have a buffer of a certain length, 32 bytes for example, and you have a function like scanf, read, gets, fgets that does not have a limit, and you can fill the buffer and start overwriting in addresses that you shouldn't. How we could protect ourselves, let's say, how could we fix the bug here? Also, one good countermeasure would be void handler, for example, and printf naughty boy try to buff, and here it goes, takes signal, and here we initialize it with signal and segv, which is the segmentation fault value, and here we call our handler. And right now the program, if we gcc again, okay, where was it? So if we go here again, so what's your name, boy? And yeah, okay, exit. Last try, I promise. What's your name, boy? And now instead of producing a segmentation fault, it says naughty boy try to buff, and didn't produce any error. Okay, it's okay, I misspelled the word. And what are the countermeasures for that? One is this. You can have a handler function that just exits and the program handles itself. Otherwise, you can choose another function, or for example here, the buffer is 32 bytes. You can add a limit to scanf, something like this. This one will save you from buffer overflows, or otherwise you can do something like this. You can use a read name, and here again 31, so it reads less than the size of the buffer. Or you can also do something like fgets name 31 and stdin. Again, there is limit to the bytes you write, so this is safe. And never, do not use this. No, we don't. This is illegal, this is forbidden. Do not ever use the gets function. And if you don't believe me, man gets, and never use this function. Yeah, don't do this. And also you can always use the manual page to get the functions. For example, man read, it will tell you it needs this library and what it returns, return value on success, blah blah blah, what are the arguments and so on. You can do it for many functions, for example fgetch. Same here, and we'll also include the family of similar functions. Guys, I think it's a wrap. I explained almost anything we needed for understanding what a buffer overflow is, how to patch it, how to write it, how to exploit. Last thing I forget. Here you can also add this. This one is, it actually creates a canary. This is the Checkec and the file name. So we see canary, this is canary, and it says yes. So it adds another layer of protection, which is the canary, that I will explain in later videos. So guys, if you have any questions, you can leave a comment and give me some feedback. If you enjoyed the video, you can like it and subscribe to the channel. And thank you very much. See you on the next ones. Bye.